So I will introduce the final proper talk of the summer school. From last year, I'm pretty sure this was the talk, this is going to be an updated version, of course, but this was the talk that was most popular in feedback. So I'm excited about it, and I hope you are too. So for this, I'm introducing my colleague, Lewis Hammond, who's Research Director of Cooperative AI Foundation. You've all met him. Lewis serves as Research Director of Cooperative AI Foundation and is a doctoral candidate in computer science at the University of Oxford. He is also affiliated with the Center for the Governance of AI and is a Pathways to AI Policy Fellow at the Wilson Center. His research concerns safety and cooperation in multi-agent systems, motivated by the problem of ensuring that AI and other powerful technologies are developed and governed safely and democratically. Currently, his work focuses on strategic interactions between agents of different computational capabilities and has been funded by the UK Engineering and Physical Sciences Research Council, OpenAI, and the Long-Term Future Fund. Before coming to Oxford, he obtained a Bachelor in Mathematics and Philosophy from the University of Warwick and a Master in Artificial Intelligence from the University of Edinburgh. Welcome, Lewis.
Thanks, Cecilia. Okay, and thank you all for making it to the end of the summer school. It's lovely to see you all sitting here, and yeah, I hope I'm going to make the last talk worth your while. Yeah, it feels like a little bit of pressure going last, actually. I didn't really anticipate that this is what was going to happen in the schedule, but here we are. I'm not going to be talking so much about kind of concrete object level research. I'm going to be thinking a little bit more about the kind of meta level of doing research and kind of finding problems, how to solve impactful problems, how to do so effectively, and so on. And so for a little bit of context, and also just to point you in the direction of some other things that you might find useful, I gave, as Cecilia mentioned, a kind of similar talk on this topic last year. And I feel like I have this finite list of advice that I give to people and tips and tricks. And I covered a lot of it in last year's talk, and I'm going to do my best not to repeat myself. But that does mean that there are going to be quite a few things in that talk and also in this accompanying blog post that goes into more detail and has loads of links and so on. And in fact, one of the things, if not the thing in that post that I would direct your attention to more than anything else, is this section at the end of the post, is resources list, which is basically a list of advice and information for people either who are junior researchers or just researchers more generally, thinking about AI or sometimes AI safety and AI governance specifically. And these people are far more, this is only a fraction of the list, by the way. This is all I could fit on the slide. The list is much longer, and these people are much more successful and important and impressive than I am. And so I basically created my resource document by stealing all the best bits of their advice that were I thought were most relevant to me. But I think it's an extremely valuable use of time to just sit down and read through all of these. I did so when I was in the first year of my PhD, and it was probably, in terms of unit time, usefulness per unit time, probably one of the most valuable things that I did in my entire PhD was just sit down and read through a list of research advice. Helps if you can do this a little bit earlier so you learn these things faster. But yeah, highly recommend you go and check out those resources. Cool, so things I'm going to cover in this talk. I asked this question on Slack the other day, and the people have spoken. And what the people want, it seems, are common mistakes I see made by junior researchers. I'm going to try and tackle the top 3. So common mistakes I see made by junior researchers, topics I wish more people were working on, and we'll finish with the spiciest takes on cooperative AI that I can come up with. Parentheses, may not be especially spicy. I've tried, but we'll see how we get on. You can be the judge of how spicy they are. I realize that's a lot of stuff that I'm not covering, and also maybe some of those things are more relevant to you than others. And so hopefully as well, I'm going to leave a bit of time for Q&A at the end. I'll also be floating around for the rest of the evening and also tomorrow morning, so you can come and pepper me with questions then, or just email me or whatever it might be. Okay, so I'm going to start with this first thing that got the most upvotes, which is research mistakes I often see. Okay, big fat caveat in front of all of this, that I'm sat in front of an audience who are, already in many cases quite capable researchers, and in some cases are more senior researchers and more experienced researchers than I am. So this is going to be slightly less directed at them, and I kind of like apologize in some ways for kind of telling you these things. With that said, the advice I'm going to give, even I, wow, sometimes struggle to kind of follow this advice especially well. And I think really just like drilling it into your brain and kind of making it like a reflex is still very valuable. So I hope that even if you've heard most of it before, or even if these things aren't new to you, then you'll still learn from them, or hopefully they'll be a little bit useful. Okay, big fat caveat out of the way. So I'm going to break this down into like things that happen before a project, during a project, and after a project. And these are just like the top high-level things that I think of, or the mistakes that I run into most, supervised, like, I don't know, maybe like 10 to 15 kind of like master's level, like early PhD level projects at this point. So definitely not like tons, but like more than maybe most people in this room potentially. And so yeah, these are just some things that I run into like again and again and again. So hopefully these are useful to point out. So first main thing is like a miscalibration on like what is actually novel. AI researchers are more guilty than most of reinventing the wheel. And I think there's a couple of different reasons for that. The first is that like our field touches upon like many other fields. And so there's naturally all these other things that occur elsewhere that we may not know about. And also our field focuses much more on kind of conference publications and moving fast and not journal publications. And this encourages these kind of like, people to kind of duplicate effort. So your null hypothesis, whenever you begin a new project, is that someone else, probably someone in like 1995 at like the University of Toronto or whatever, or classically for me, it's often like some like French economist from like the late 80s has like already solved the problem that you wanted to solve. And so that should be your null hypothesis. You should work hard to invalidate that hypothesis before you begin your research project. So this is kind of related to this overconfidence idea, this idea that what I'm coming up with is like new and no one has ever thought of it before. Sometimes that's true, but like, you got to check yourself. The flip side of that is this paralysis, where you think that all the interesting problems have already been solved. And this is also absolutely untrue and is a kind of the opposite failure mode that is kind of like almost in some ways like a little bit harder to steer away from. And in fact, sometimes you can end up kind of overcorrecting on this. So it's something to be aware of. Another thing I wish I saw more of is people kind of knowing the basics and like just sitting down and like reading textbooks. It's all like reading sections of textbooks. The number of kind of like, I'm getting like increasingly tired of just seeing like, sorry, this is like the Lewis gets to rant for like 45-minute segment of the summer school. So, sorry, the door's there. Right, I see so many projects where people just are like looking at interactions of like LLM agents and things like this, but they just like very clearly just don't really know that much about like game theory or like the basics of like these strategic interactions or like what we should be expecting to see and why. And it's just very frustrating because they just miss so many things, and it means that the papers just like aren't very good. It's not that the researchers aren't capable, it's just that they miss these like little obvious things that if they had a bit more background, they'd be able to spot no trouble. Okay, classic thing, I've done it, everyone's done it, work on too many projects, don't do it. Quality over quantity is the kind of like, the slogan. I now am reaching the end of my PhD, and this is like one of my bigger regrets is that I've focused too much on doing too many different things instead of just like smashing out a really small number of extremely high quality things. When I'm not applying for faculty jobs, at least not right now, but if you do, the faculty job board do not care about like, your 17th publication of your PhD, which was accepted into like some small workshop and on which you were like, 6th author out of 7 or something. No one cares. They care about your top 3 like big research hits and big research wins, and you should be optimizing for those. That's cool because PhDs are short and they'll go quickly, but that means you only really need to like smash out like one really, really good thing each year, and you'll end up with a kind of stellar profile. You can take this advice too far, but I think this is, most people are on too much the other side. So as a general rule, having like one major first author project and one secondary project to work on is like a good rule of thumb. You'll probably have a little bit of spare headspace if you do this, but that's actually great. Because you need the spare headspace to be kind of reading around, thinking about things. If you're like constantly just like trying to play catch up with projects all the time, you won't be able to think of anything on the side. Another classic thing is just not planning enough. So first step, make a plan. Okay, what does make a plan means? It doesn't need to go into too much detail, but basically like have in mind like what the trajectory of the project is going to look like, what the key milestones are, what you're going to test first, what if that doesn't work, you're going to test second, how you'll know if you're on the right track, all of these sorts of things. Sketch out, even maybe kind of early on if you can, a structure for the paper. Or for the kind of write-up of what you want to communicate. Not because this will be what you'll kind of just map to and then you have to stick to, but because it's useful for clarifying your own thinking about like, if you need to explain something to someone else, you know, so the kind of like famous saying goes, then this is like a good demonstration that you truly understand what you're trying to do. So first step, make a plan. Second step, follow the plan. So again, like people write a nice document at the start of a project, they share it with their collaborators, and then they never open it again. Don't do that. Yeah, pay attention to what you're doing. Adjust it, absolutely, as you go forwards, but like have a plan and adjust the plan and know what you're working towards and why. Third step, profit. Okay. During a project, classic mistakes I see yeah, this is probably the biggest one. Poor justification and threat modeling for the overall project that you're working on. So just sanity check yourself. Just like, why is this actually a problem? And also not just a problem, but like a problem that matters. Like, so you imagine you come up with an amazing solution for this problem. What difference will it cause in the world? Like, how will it change things? Ask yourself this question. Another key one is, will it scale? If it works at these nice toy agents, and in theory, that's lovely, but if you can't even, if it's impossible to even comprehend of how this could scale to, say, agents based on foundation models, then this is probably an indication that you might want to like rethink whether you're doing that project. The flip side to this is, will it be solved with scale? Sure, GPT-N might not be able to solve this problem, but if GPT-N+1 is very likely to be able to solve the problem, then again, maybe not something worth working on. Another version of this is just like, why not use the obvious solution? Sometimes people come up with this very clever, fancy, nice method, and it just, you know, they just don't think that, you know, they don't think to question that like, oh, maybe the baseline is just going to absolutely like smoke this like very complicated thing, and like often it does. And figure that out first. Don't like implement your fancy thing and spend loads of time on it, and then figure out that the baseline destroys it. Few ablations and low statistical significance. This, I think, comes from the fact that machine learning in particular, but also AI somewhat more generally, falls, in some ways at least, you can view it at the intersection of science and engineering. And engineers want to like build things and get things working, and this is great. Scientists are more my cartoon sketch, scientists are kind of more inclined to figure out like why things work, when things work, you know, how should I update my beliefs about the world based on the fact that this thing works? And so this sometimes leads people to be like so focused on just trying to like demonstrate something or get something working that they kind of, you know, don't go to like, they don't try to like destroy their own hypothesis, basically, which is what you should be doing if you're trying to be a good scientist. Okay, this is just like more of like a personal pet peeve. It's just like, I can't believe the number of people I work with who just like don't use a reference manager. You're making your own lives so much more difficult. And so, yeah, just do this. This is like the sort of thing that like doesn't matter for the first few papers that you work on, but as soon as you work on like more than a few projects and you're working with other collaborators, your reference is just going to be like exploded all over the place. And yeah, it's very, I have like, you know, like 1,500 references like stored in my reference manager now at the end of my PhD, and I can like search them, I can add my notes there, I can keep track of what I've read, what I haven't. I never have to worry about like, oh, where did I see that thing? Where did I read that thing? Just use it. Also, I like encouraging people to use like a shared folder and just like stick everything in the shared folder. Like it drives me crazy having to like, there's just like a billion Google Docs that I have access to, and like being able to find the right one in time for the meeting is just like not something I want to have to deal with. This is like, if you ever work with me, this is like, you know what you're getting yourself in for. Sorry, some people in this room work with me. So yeah, this is for collaborators as much as it is for you. This is the main point with this one. Research is not like an individual thing. It's much more fun and enjoyable and productive if you're doing it with other people. Very small one just at the end, creating new environments from scratch. I think this is a one that I especially see like more junior researchers get into. They've come up with some cool method for like thinking about cooperation and so on, and they want to be able to test it. And in order to test it, they're like, I guess I can come up with this like cool grid world or this like little language model game or something like that. And yes, you can. You absolutely can. And it is a waste of time because so many other people have already done this, and they've spent way more time and effort than you have available to you in doing that, in optimizing it to run fast, in making it nice and quick and easy to plug in and like download and all of this sort of stuff. So just look for what's out there and don't just like, again, don't reinvent the wheel. Okay, after a project. Final step. So mistakes in writing, and these are the main ones that I see very, very often. And I think, again, there's just so many people in this audience have already written papers and just like know what they're doing in this area. So I'm going to go through this quite quickly because it's probably all obvious to you. But a really main one is just like messy structure and flow. A nice tip that I like to use is when I'm writing a paper, I write out the structure headings, like sections and subsections and so on. And ideally, I also even like to write one sentence per paragraph under that subsection. And that sentence should explain exactly what that paragraph is saying. And then this whole high-level structure should flow as a nice story. You should be able to read it as like a bullet list of like indents and whatever, and it should actually make sense. And if it doesn't make sense, you're doing it wrong. Okay, this relates to the kind of one where people just don't try that hard to just figure out whether someone else has done their thing before. They just assume that probably no one has, and even if they have, my version's probably better. So yeah, they don't do an insufficiently detailed lit review. They don't sufficiently detailed lit review. This is like the classic one I see mostly for people who are doing like master's projects or like their first ever paper, is that the tone is often either falls into one of two camps. First, sometimes it's too pedagogical, because essentially this is what happened to me. After you've done like your uni degree or whatever, you're used to resources being presented to you in a way that just like explains things gently. They're like textbooks, they're like lecture notes, these sorts of things. Papers don't look like that, and they shouldn't look like that. That's not their purpose. So the tone is often just like very slow, very explanatory, tons of worked examples where they're totally unnecessary, being miscalibrated on what your audience will or will not understand, which is a hard thing to get your head around, in fairness, to start with, but it's important to do it. The flip side of this is just like poor expectations by when you assume that just like, because you're very close to the problem, everyone else is just going to follow you. They're going to know what you're talking about. So again, your like hypothesis about who's reading your paper should be someone that's smart and that knows about your topic, but that is not reading your paper very carefully and is like skeptical of any claims that you're presenting. So if you have that thing in mind, they're not dumb, they just don't have very much time, and they're like, you have to put in some effort to like convince them that you're right. That's the kind of way to approach it, I think. Mistakes in presenting, not rehearsed talks, just rehearse your talks, just do it. Not enough audience engagement. Any opportunity you have to like ask a question to the audience, I'm just like realizing I've not followed this advice in my own talk. I did rehearse it. I didn't ask the question thing. We'll see if I can fix that as we go. But yeah, if you have opportunities for audience engagement, use them. People love it. Never use slides as speaker notes. Your slides should be pretty minimal. They should be like have roughly this level of detail on them, so say I anyway. Lots of nice pictures, diagrams, like explaining things intuitively, but don't have there be reams of text. Do not rely on your slides as speaker notes. Use speaker notes if you want, but don't make them your slides. Mistakes in promotion, I think the biggest one here is just like people early on underestimate the importance of disseminating research. It's basically just like no point, I mean, there's a kind of trivial version of stating this, which is there's just no point doing research if no one ever hears about it, unless you're just doing it for like fun, which is a good reason to do it. Yeah, so basically just like, you should actually think about this. You should have like a mini marketing campaign for your like paper and so on. You should think about like, who cares about this? I'm building on the work of these like fantastic, professors or whatever, or like researchers that I'm extending the work of. Like, maybe I can send it to them. Maybe they care about it. How am I going to get their attention? Like these sorts of things. Maybe I can, meet them at a conference and talk to them about my work. All of these sorts of things. Have a blog post for every paper that you write that like gets the key messages across nice and crisply. This will help people read it. Do like have a Twitter thread. Make sure you have your own personal website where you're like adding all of these things just as like links and so on. Super easy stuff. And it feels to begin with like pretty slimy. Or at least I felt pretty slimy doing this, but it's just like really important, and it's just like that's how you get the word out about all the amazing work that you're doing. Okay, where I would like to see more work in the cooperative AI space. These are, I guess, like my views and not necessarily the views of the Cooperative AI Foundation per se. They overlap, understandably, a lot with the views of the Cooperative AI Foundation. Coincidence. Yeah, so I just kind of came up with these mostly on the top of my head. Cecilia did point to a slide in her presentation, which was about these kind of like key grant-making areas. We have loads more detail there about with like bullets underneath of like important research questions that we'd like to see people working on. I think I also hopefully plan to publish later this year more like a kind of like a kind of big list of kind of like small, like kind of bite-sized project questions and people can just like dive into and maybe like, work on during their PhD, maybe do their master's thesis on it, like maybe like internships and things like this. I think this is nice to have this like list of kind of questions for people to kind of, take things from and kind of attack and so on. So I'm going to try and come up with something a bit more concrete. So in the meantime, this is going to be a bit more high level. And yeah, maybe we can get into some details in the Q&A. Okay, so first big category of stuff that I would like to see more work in is agent infrastructure. In particular, I think IDs and reputation systems are things that are not like massive deals in their own right, but that I think a lot of stuff kind of builds upon. Like a lot of the more general kind of cooperative AI solutions that we think about tend to rely on the idea that, for instance, you know roughly the agent that you're interacting with, and or if you've interacted with them before, you know that, and you can kind of recognize that they're the same agent. There's big questions about like how we'd actually build these, what we can build on top of that's already out there in the world, and the ways in which they might slot into some of our kind of like existing kind of tools and algorithms and like thinking on how to improve cooperation or prevent agents from cooperating and so on. I think a similar thing can be said for commitment devices. There are both kind of theoretical and practical challenges here. The theoretical thing is more about kind of like, what is the structure of these commitment devices? How are agents committing to things? Is this unilateral commitment? Is this multilateral commitment? Are these conditional commitments and so on? When do we want commitments? We might not want commitments that allow agents to make credible threats to one another. We might want them to be able to make kind of cooperation promoting deals with one another and so on. So there's some theoretical challenges, also just a bunch of practical challenges about this as well. And we might be able to build on lots of stuff to do with existing internet protocols or cryptographic protocols for these things. But we also have to be aware of the fact that we might end up with these very powerful advanced AI agents that are trying their hardest to kind of subvert or kind of get around these protocols as well. And so that's maybe in some cases not such a thing we have to deal with. So yeah, again, communication protocols is going to be come under that too. We're now starting to see work on this. So like, I can't remember who it was in their talk, but someone mentioned MCP already. I think there's this other one, A2A. There's like all sorts of other things that are kind of coming online now. And these are being built usually by folks in industry. And I would love to see more thought about the properties of these kind of communication protocols and how those properties change or how those properties impact questions in cooperative AI, in kind of more broadly kind of AI safety, the governance of agents and so on. And I think, again, all of our solutions in that space are going to have to build on top of this kind of underlying infrastructure. And so getting that infrastructure is right is important. Cool. Thinking more about kind of real-world applications. I'd love to see some more kind of real-world case studies. One thing I'm working on with a collaborator at the moment is looking at the impact of more advanced AI agents on financial markets. There's kind of two versions. There's two sides to this in some way. One is just like how will more advanced AI agents impact financial markets and their stability and volatility and so on. And the other one is the fact that we have already in financial markets and have had for some time high-frequency trading algorithms that interact with one another and that are very much not on the same side, and they interact at great speeds and great scales and so on. That's the entire point of using them, blah, blah, blah. You've heard that spiel from me before, I'm sure. But there's also a bunch of techniques that people use in that world to prevent these things from going wrong. So we have kind of circuit breakers, we have kind of registration regulations, we have all of these sorts of things in place to help kind of prevent the next flash crash or whatever it might be. And it still happens, but it's, people work on this. And there are other cases, thinking about people like conflict and so on, and kind of military situations or other high stakes scenarios that I think basically we can learn a lot from, and we can kind of concretize our thinking more by kind of trying to imagine like visions for like what applications might look like in that area and how we can head off some of the things that might go wrong. Cooperation and learning in LLMs. So yeah, a few different categories here. basically, cartoon picture of like the last few years of AI research and research in cooperation and stuff like this has been like, cool, multi-agent RL was like, at least when I was first getting into this space and thinking about these things, and I'm, only a youngin', yeah, people were thinking about multi-agent RL and cooperation and so on, and then LLMs came along, and everyone was like, oh no, all of our assumptions about what AI agents are going to look like are wrong. Like LLM agents don't have like a concrete utility function and like this like specific action space, and like we do this pre-training thing, and then we just set them off in the world, and then they do stuff. We're not like training them as they go. We don't start from scratch, etc. And like, oh man, we're going to have to rethink everything. And it's like, no, we're not going to have to rethink everything. And in partly that is because like, RL training is now starting to work with LLM agents. People are like doing this. And I think that means that like a bunch of the things and insights that people had before are going to come back to being more relevant, but we need to think carefully about how we might kind of translate and make use of those in the setting of LLM agents. So that's the kind of broad pitch that I'll throw out there. People might disagree, but that's what I will say. So yeah, thinking about different training paradigms for foundation model agents, the impacts of scale and data. One of the projects I'm working on at the moment that I'm quite excited about is basically like, yeah, how cooperation and coercion in the context of different kind of foundation model agents like changes with the scale of both the system, the amount it can reason, maybe the amount of ground truth data it has had to learn from, all of these sorts of like, yeah, big picture kind of ingredients to the kind of ML pipeline. There's also some interesting ideas around like the effect of agents' training data on their kind of dispositions and kind of propensities and biases and so on, and if they're learning from human data, how that will affect their willingness or ability to cooperate with one another. Bunch of open questions there. And then I guess there's like two other things that I want to flag. So one is this idea of kind of information design, this idea of being able to, as someone with information, kind of reveal that information strategically so as to encourage more cooperative outcomes. And people have thought about that in game theory and mechanism design, these sorts of things. And people have thought about it, beginning to think about it in machine learning, multi-agent reinforcement learning. I don't think really people are thinking about this in the context of LLMs yet. So there's questions about how do we scale this, where can we test and apply it, and then exactly the same questions for broader kind of mechanism design questions. This adaptive here is just doing the work of thinking about the fact that we can not just have humans that do this information design or mechanism design, and maybe not just like static algorithms, but that we can have machine learning agents themselves that learn in order to kind of like increase, promote more cooperative outcomes. Who recognizes, I'm going to do my audience engagement thing. Who recognizes the picture on the bottom right? We got like almost half the hands, but not quite. Okay. The picture on the bottom right is the AI economist. If you have not looked it up, you should Google it. It's really cute. It's from Salesforce. Weirdly. Salesforce do AI research. There you go. And some wonderful folks at Harvard as well, and there's overlap there as well. So it's really, really nice work. And it's basically about this like bi-level kind of reinforcement learning situation where they have like an AI economist who sets tax rules, who tries to kind of trade off against the efficiency and the welfare within this little mini kind of agent society who, these individual agents run around, collect resources, build things, but they have different kind of skill levels and so on. And so some of them are able to kind of benefit more than others from their kind of capabilities. And yeah, there's this trade-off between fairness and efficiency, and they solve this using this kind of multi-agent reinforcement learning setup. It's very cute. It's got some nice ideas in there. And yeah, the question is just like, can we scale this up? And where can we apply it? And how can we make use of these ideas? Okay, final section within this broader category, understanding and evaluating collective behaviors. So I think we need more and better multi-agent evaluations and protocols for control in the sense of it's kind of annoying, unfortunately named, but some of the work that, folks like Redwood Research are doing. If you haven't heard of this idea of AI control, so I'm not talking about control theory here. I'm not talking about like the control problem in the broader sense of like the AI safety issue and so on, but specifically this notion of AI control, which is this own kind of like special brand of thinking about how to deal with situations in which your AI agent that you are trying to monitor and evaluate is doing its absolute best to subvert your kind of monitoring and evaluation protocol. And people have been thinking about this in the case of single agents, but not multiple agents. So I think there's a bunch of work to do there. Again, some work on like collusion and evals for collusion and coercion, new multi-agent control protocols. A related one to this is just actually detecting and preventing collusion. There are about 7 billion papers on we got 2 reinforcement learning agents to learn with one another in a like basic market duopoly, and they learned to set super competitive prices some of the time. Don't write one of those papers. Write a paper instead, or go work on a project where we think more carefully about methods for actually detecting and preventing collusion at scale with like large, powerful agents who might have very complex and potentially secretive strategies when it comes to working together with one another. I think there's a lot of interesting theoretical work around kind of information theory and steganography and so on here. Also tons of empirical work to be done. Yeah, mostly people have just been thinking about like nice, cute ways of demoing this like thing in the context of very basic agents, not about more advanced agents and not about how to stop it from happening. A related one is monitoring large networks of agents. I think there's just tons of like insights to be gained here from probably, I think, I'm no expert in these other domains, but from other people who think about how to govern very large, complex dynamic networks of kind of systems, be these kind of IT infrastructure, or be these markets, or be these kind of traffic networks, all these sorts of things. And we might want to soon apply similar techniques to vast networks of AI agents that are communicating with one another, communicating with humans, interacting with a bunch of critical infrastructure and resources, maybe gathering resources, all these sorts of things we'll want to keep an eye on. And then the final one is much more of like a theoretical one. Again, just another project I'm working on, so of course I'm going to think it's important to work on, but is questions around defining and detecting collective agents. When is it helpful and useful to think of a group of agents as being a single agent? And will that single agent end up having goals, behaviors, capabilities that no individual agent within that collective has? I think this is an important and interesting question. And yeah, I have some ideas about how to make progress on it, so I'm hoping we'll see some more work there soon. Okay. We're getting there. I'm gonna now finish with some maybe spicy takes on cooperative AI, and you can be the judge of how spicy they are. Yeah, I'm just gonna throw these out. Again, it goes without saying that these are very much not the views of the Cooperative AI Foundation necessarily. These are just my views. I think actually they're like mostly pretty defensible and not too crazy. Yeah, these are some things I think, and that for what it's worth, we had the retreat immediately before this with some bunch of senior researchers. We did a similar polis thing where we kind of vote and disagree and agree on things. And I threw many of these into the polis, and many people disagreed with me on at least some of them. So there's some like evidence for you that they're A, at least like somewhat spicy maybe, or B, that at least like they're just my opinions and they're not representative of the cooperative AI community as a whole. So there we are. Okay. First one, I think capabilities matter more than dispositions when it comes to cooperation, at least in the slightly longer term. I think sometimes people have this idea that what we need for cooperative AI is we just need the agents to want to be cooperative. We just got to encourage them to be cooperative. And as soon as we make them want to be cooperative, yeah, we're sorted, done. I think that's really not the big problem. I think that as soon as you have agents that can be optimized very effectively for pursuing the goals of self-interested actors who are building and deploying those systems, then those agents will be pursuing those objectives to the extent that the alignment project succeeds pretty well and pretty capably and pretty competently, and they will not necessarily be interested in cooperating. So the question is much more about, can we give them the ability to cooperate with one another, and or can we build the kind of like infrastructure surrounding them that makes cooperation a kind of like stable and good strategy for them to pursue? So I should also have included maybe some kind of like infrastructure or something as well as this thing about capabilities. But it's much less about the kind of dispositions of these agents. Coordination problems will disappear with scale, so I claim. Yeah, by coordination problem, I basically mean I really love this meme. It's really good. There's also another half to it about like, which is like taking a dig at like statistical learning theory, which is a bit mean, but it's also funny. And yeah, by coordination problems, I basically mean problems where everyone is on approximately the same side, where everyone has basically the same objective. Caveats here is that like there are very few situations in the world where we all have precisely the same objective. That doesn't really happen, like down to the T. It could happen in theory with AI agents, but even then it's unlikely. But for example, like a case like autonomous driving, right, where like it's not full cooperation because I'm trying to get where I'm trying to go, you're trying to get where you're trying to go. If you're being a bit slow, maybe I want to kind of overtake you, vice versa, these sorts of things. But any small benefit that I can gain by kind of like, overtaking you or to kind of like, making you worse off is often going to be vastly, vastly outweighed by the risk of like a very serious accident, which is just much worse for me. Like a car crash is just much worse for me than being able to just like kind of cut you off at a junction, like, haha, now I'm slightly further ahead of you. So it's basically a coordination game. And from my perspective, I'm not really very interested in these problems because I think that this is, as they like to say, a skill issue. And I think the much more interesting problems are the ones that stick around after, as capabilities scale. And I think these ones are risks of conflict in mixed motive situations and also risks of collusion. I actually think that in many cases, those can get worse as AI capabilities get better. And so this is the sort of thing we need to be focusing more on. Cool. Again, my personal take is that theory is undervalued. I think people are just like, looking to do big, fancy, shiny things with like machine learning models, and like, I wish they'd think more about the theory stuff. The flip side to this is you can't just do theory in a vacuum, and if you have a nice bit of theory, but there is, again, no way that you can think of that you can possibly connect it to language model agents or foundation model agents in a way that makes sense, then maybe that's a strong update that your theory is not going to be especially useful, at least in the near term. Cool. In general, I think evals are overvalued and overrated. I think too many people are spending too much time on building evals and often duplicating each other's work as well. So I think evals are extremely important, and I think I'm very happy that lots of people are working on them. I just think that we're probably spending a little bit too much time on them. Flip side to that is actually that I think the field, is a kind of subfield of cooperative AI, is almost like a small counter. Like a counterexample to that. I actually think that in cooperative AI specifically, we do not have that many good evals, and I would actually love to see like much more work on evals in the cooperative AI space specifically. And by that, I don't mean we got some language model agents to play the iterative prisoner's dilemma, because again, there's just about like 1 billion papers on that, and it's not that interesting or useful. But I'm thinking more about kind of like looking for specific capabilities or maybe propensities, the things that Cecilia was kind of talking about in her previous talk, or thinking about kind of more realistic kind of environments and settings, kind of actual thinking through the threat models of the things we might be interested in, building evaluations to test for those. This is maybe like, I don't know how spicy this is in this room, but I think more people's plans, and also their research plans, but also, like life plans, should be robust to the possibility that we may reach AGI like pretty damn soon. And this is not my timelines, by the way. This is not representative of what I personally think, but I do put some probability mass on this. I don't think this is crazy at all. And I think, this is really important to bear in mind and to like seriously internalize. That's like, I think, for example, I've been joking to people now that like, oh man, I've been doing my PhD for a while now, but like, at least I'm going to be able to just about finish it before AGI could have finished it for me. Or like not AGI, but like graduate level AI researchers, which are like, I don't know, not that far away, I don't think. And so, yeah, this is like, for a bunch of people who want to do maybe like graduate level AI research, this is something to like seriously think about. And yeah, I don't know. I don't know what more there is to say there. I think there are lots of things to do, by the way. I think there's still like tons of important work to be done. I think doing research now is like extremely valuable and high leverage, and like that's why we run the summer school. That's why we have these things. That's why we want people doing this research, because it's so important, and now is the time, or now could be the time. So yeah, don't let that dishearten you, but just think carefully about like what this means for your research career. What questions are like especially important to answer now? What sorts of roles and positions might be more useful. If you were banking on being a software engineer or something like this, then maybe like play around with like Claude Code or something and like reevaluate your career plan, or like think seriously about your career plan. So yeah, things like this basically. Cool. I won't belabor that point. I already have belabored that point. I won't belabor it anymore. We're getting towards the end, by the way. You'll be free soon. This is one that I think is like, yeah, this is one that I get like, I think is like quite an obvious point, and I think most people don't think is as much of an obvious point. I think there's a narrative that sometimes people either tell others or tell themselves that they go to work at big AI companies because they think that when we get to very, 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 very powerful AI systems that are being kind of deployed or governed or kind of like used for certain things out there in the world, that when it gets to like crunch time, that, you know, it'll probably be these AI companies developing those AI systems. That I very much agree with. Not in that I support that idea, but that I think it's likely, unfortunately. But they think that if they're in the room, if they're in the companies, then they'll be able to exert some influence over how this thing goes, and maybe, just maybe, they'll be able to steer things into a slightly better trajectory, and this will be very good for the world. And I am very much on board with the motivations of those people. I think they are kind of deluded if they think that they will have like any meaningful influence over like anything when it comes to crunch time. If you're like a mid-level research scientist at like a big AGI company, a big AI company, or whatever, basically think your opinion doesn't really matter at all. When it comes to these big decisions, it's going to be CEOs, it's going to be people in the board, it's going to be heads of state, it's going to be people in the military, it's going to be, whatever. These sorts of folks who are going to be calling the shots and making the big decisions. I do think, though, that there are still excellent reasons to go and work in industry. You can do work in industry that you can do nowhere else in the research landscape that is extremely important and high leverage. And so this is a great reason to potentially go work in industry. And if you're like, if you lead a research team or if this sort of thing, or even if you're a bit more junior than that, you can still steer the company towards doing some of the research that is like more impactful or more useful for the big picture questions. So there's definitely some ability that you have to do that, and that can be a very good reason, but it is not the same thing as like having any influence at crunch time. Cool. Improving human cooperation is like on the same order of magnitude as important as preventing AI conflict. So I think we tend to think sometimes a bit more about the second class of things. We want AIs to work well with one another and so on. But actually, I think that using AI to improve the ability of humans to work well with one another and cooperate, especially in very high stakes situations, is a big bet and an uncertain bet, but I think a very, very important bet and could have huge, huge, huge upsides. So I'm very bullish on this overall area and topic, as I think is somewhat represented in our speaker lineup as well. I've been told I have a very small amount of time left. Cool. I'm getting there. I've got a few slides left, not very many though. I think we need more on the margin, I think we need more people with expertise in complex systems instead of more people with expertise in game theory. I'm a game theorist. I love game theory. I think it's very insightful, very useful. I build lots of my thinking around it, especially when it comes to AI. But man, I wish I knew more about complex systems, because many of the problems, when I think really hard about what's likely to go wrong or right in the world, look like complex systems problems. They do not look quite as much like game theory problems, although I think both lenses are extremely valuable. So if you're looking for something to learn about and you think, what should I work on? What should I think more about? If I'm looking to just learn stuff, my pitch would probably be for people to think much more through this kind of lens than through other sorts of lenses, and to try and tackle some of the thorniest of problems that we've been talking about in this thing from the perspective of complex systems over game theory type stuff. Again, this is probably something that maybe some of my colleagues at the foundation and maybe others in the field would disagree with, but that's where I'm at on it right now. I think doing a PhD is underrated, even if AGI arrives soon. I think this is, this is an unpopular opinion somewhat, although maybe less so in this room, I'm not sure. Why do I think this? Basically because you can use your PhD as a bit of a platform. It's like a kind of safe space. You should be, hopefully, provided funding and a place to live and some people who can support you to do research and things like this. And yeah, hopefully a lot of freedom as well to work on whatever problems you think are the most important ones. And it also gives you freedom to go off and do other things. So, I started working at the Cooperative AI Foundation during my PhD, still doing my PhD. But yeah, you can do other things like that, which are great value, I think. You can also work on maybe like governance things. You can take internships. You can go on research visits. You have a lot of freedom during your PhD, potentially, if you play your cards right. And so there's a lot of impact you can have even as a PhD student. And if it doesn't work out, or if something more important or exciting comes up, you can always drop out. Right. I'm not endorsing dropping out, but I'm saying you can. Final thing. I think that AI governance is at least as important as AI safety and cooperative AI. I think that even if we solve all the big technical AI safety problems and cooperative AI problems, maybe I think the cooperative AI problems, if we solve cooperative AI as well as the rest of AI safety, then I think, sort of in some ways of thinking about that, you just use the AI to help us solve all the governance problems as well. So that's why I'm like kind of this AI for human cooperation type thing. I think this is a really big deal. But yeah, if we just solve a bunch of like alignment issues or whatever, I still think that just like many of the big AI risk concerns remain, and I don't expect necessarily things to go especially well for the kind of median person. So yeah, I sometimes like to characterize this as thinking like, if I could just magically like snap my fingers and create like 100 like top tier AI governance thinkers and researchers, or like 100 top tier like AI safety researchers and thinkers, I think it's a tough one, but I think I might prefer the AI governance researchers, maybe. I'm not sure. Basically, I think that AI governance is like really, yeah, just very important. I will also say that despite probably mostly being a room of largely like technical folks and so on, you are therefore actually with that technical expertise uniquely well positioned to help on some of the trickiest questions in AI governance. And there's like really a kind of deficit of kind of knowledge and of people working in both areas and who have knowledge of both worlds. And so if you're interested in these sorts of ideas and careers and thinking, then I think this is something you should explore further. Okay, I don't think we have time for questions because you guys all have to present lightning talks and I want to see those. But I will be floating around and you can ask me your questions whenever else you get the opportunity. Thank you all for listening.